Hello friends, welcome to the lecture on mechanisms in organic chemistry part 5. Nucleophilic substitution. Bonding in halogenoalkanes. When we look into nucleophilic substitution reactions, we consider compounds like halogenoalkanes, which are very easily studied for such kind of substitution reactions. Halogenoalkanes, also known as haloalkanes or alkyl halides, are compounds containing a halogen atom, that is fluorine, chlorine, bromine or iodine, joined to one or more carbon atoms in a chain. The interesting thing about these compounds is the carbon-halogen bond, and all the nucleophilic substitution reactions of halogenoalkanes involve breaking that bond. So, in such compounds, the halogen carbon bond is being cleaved or broken to get a substituted product. The polarity of the carbon halogen bonds. Now, why the carbon halogen bond breaks? It is due to the polarity of the carbon halogen bonds. With the exception of iodine, all of the halogens are more electronegative than carbon. So, looking to the electronegativity values in the Pauling scale, we see the electronegative values which are means the electronegativity of halogens is more than carbon atom. The values are higher. That means that the electron pair in the carbon halogen bond will be dragged towards the halogen end, leaving the halogen slightly negative and the carbon slightly positive. So, in polarity phenomena, what happens? The covalent bond is polar in nature. That is, one of the atom becomes slightly positive and the other becomes slightly negative. The one which attracts the electrons or with a higher electronegative value attracts the electron and becomes slightly negative, and carbon becomes slightly positive. So this is how polarity is developed in carbon halogen bond. Imagine a negative ion approaching the bond from the far side of the carbon atom. So here we see the negative ion approaching the bond from far side of the carbon atom. This carbon atom is slightly positive and the halogen atom is slightly negative. So the electrons are repelled towards the iodine end of the bond. So this shows the induced dipole setup. Dipole means there are two poles, positive and negative pole. The fairly small polarity of carbon-bromine bond will be increased by the same effect. So, where will the nucleophile go and form a new bond? It will go and attack the carbon atom. Since nucleophiles are species with negative charge or they are electron rich, so the electron pair can be donated to the parts or the ends which are electron deficient. So here carbon, being electron deficient, receives electrons from the nucleophile. In all these nucleophilic substitution reactions, the carbon halogen bond has to be broken at some point during the reaction. The harder it is to break, the slower the reaction will be. So here we see in nucleophilic substitution reactions, the carbon halogen bond has to be broken. And if it is difficult to break the bond, the reaction will be slower. The carbon fluorine bond is very strong. stronger than CH and isn't easily broken. So, the substitution of fluorine becomes difficult. It doesn't matter that the carbon fluorine bond has the greatest polarity. Although fluorine is highest electronegative in the halogen series, yet the bond is broken very slowly. The strength of the bond is much more important in determining its reactivity. We therefore expect fluoroalkanes to be very unreactive. In the other halogenoalkanes or alkyl halides, the bonds get weaker as we go from chlorine to bromine and to iodine. That means that chloroalkanes react most slowly, bromoalkanes react faster, and iodoalkanes react faster still. So rates of reaction of the alkyl halides is that the alkyl iodide is fastest and bromine slower and chlorine still slower. Where the sign is red is less than, or in this instant it is slower than, and R represents any alkyl group. So here we have come to know the reactivity order of alkyl halide towards nucleophilic substitution and what is the basic phenomena behind the nucleophilic substitution in alkyl halides. It is the polarity of the alkyl halide or the carbon halogen bond which is taken into consideration and nucleophilic substitution reactions take place. Thank you.